In the first example, we are asked on this one to find a probability, so this is not just a count. We want to find the probability of getting 2 hearts. If you're pulling cards out of a deck of cards without replacement. Alright, so since this is without replacement, this means then that once a card is pulled, it's not going to be put back in the deck. So repetition is not allowed, and on these ones, order will not matter as well. So it doesn't matter which heart you necessarily got first and which heart you got second. You just want to get 2 hearts at the end. So let's figure out the denominator first. So since order doesn't matter, it will be a combination. There are 52 cards total in the deck, so that'll be our value for n. And out of those 52, we want to pull 2 cards. That'll be our value for r. So if we just look at the denominator, computing this, 52 choose 2. There's 1,326 ways to pull 2 cards out of a deck of cards. Now out of these total ways, let's find out how many ways we could just select 2 hearts. So now we'll start building our numerator. How many ways can this event be satisfied? Again, order doesn't matter, so this will end up being a combination. There are 13 hearts total in the deck, and out of those 13, we want to pick 2 of them. So then the numerator will have 13 choose 2, which evaluated would be 78. So there are 78 ways to get 2 cards that are hearts, and then 1,326 ways to get 2 cards out of the deck. So this would be the count of how many satisfy our event out of how many outcomes total in the sample space, and then this simplified would end up being 1 out of 17. Let's take a look at this next example about pulling pens out of a container. So we've actually looked at this previously. So there are 24 pens in a container. Now unfortunately 3 of the pens are defective. What's the probability that you randomly pick 2 pens out of the container without replacement and they are both defective? So we want to find the probability that they are both defective. Now we originally solved this problem in section 11.5 when we did problems involving the word and, but let's review it again and we'll learn a different method for computing the probability. So in this one first, let's take a look at our sample space. So on these ones, the 2 pens that you pick, the order is not going to matter. It's just going to matter that you pick 2 of them. So this will end up being a combination. And then out of 24 pens in the container overall, you want to pick 2 of them. So that ends up building my denominator, which again, if I just evaluate this, 24 choose 2 would be 276. So that's the number of ways of picking 2 pens out of this container. So now let's take a look at how many ways our event can be satisfied that they are both defective. So for the 2 pens being defective, again, order doesn't matter. It just matters that you pick 2 of them. So that'll be the size of my space, and then out of 3 pens overall. Evaluating the numerator then, 3 choose 2, there are 3 ways that could happen. This fraction over here, that if we simplify it, will give us 1 over 92, which is the same probability we had computed in the previous section. This one is just utilizing the idea of combinations instead. Our next example involving combinations will also be a scenario we looked at previously. So given a class of 12 girls and 10 boys, 5 members at random were chosen to form a committee. So remember when we talked previously, we said a committee, the order doesn't matter. Now the question is, what is the probability that the committee will consist of 3 girls and 2 boys? So what's the probability that you get 3 girls and 2 boys? Alright, I like to build my denominator first. So for the denominator, overall at this point in time, you have 22 people total, and you need a committee of 5. So the denominator, since order doesn't matter, we'll look at a combination, and out of 22 people overall, you want to choose 5 of them for your group. So 22, choose 5, there'll be 26,334 ways to just pick a committee of 5 people out of this group of people. Now let's talk about how many ways our specific event can be satisfied, which is 3 girls and 2 boys. So in these types of problems, let's pick the girls first, and then we'll pick the boys second, and then we'll multiply those two things using the fundamental counting principle. So in terms of picking the girls, it'll be a combination out of 12 girls. We want to pick 3 of them. There are 220 ways to just do that. Once we choose the girls, we will need to then choose the boys. So again, order doesn't matter, so it'll be a combination. And out of 10 boys, we want to choose 2 of them for our specific set. There's going to be 45 ways to do that. So if there's 220 ways to pick the girls, and then 45 ways to pick the boys following that, multiplying these together, you'll get 9,990 ways of choosing 3 girls and 2 boys out of all of the possibilities, and there was 26,334 possible committees that could be formed. So then this ends up forming our probability, which then can simplify to 50 over 133.